Hello, everyone. I hope you're all having a great day and are looking forward to the third workshop in the Generative AI Educate series with Boba Network. Today, we have a really exciting workshop by Souradeep from Berkeley, and he will be giving his presentation on implementing hybrid compute in Codecaster.
Hey everyone.
Hey, well, Souradeep, the stage is all yours. Whenever you're ready to share your slides and begin, go for it.
Perfect. Thanks so much, Adriana. Just try sharing my screen. Perfect. So, hey everyone. I'm going to be talking about Codecaster today, which is built using hybrid compute and for hybrid compute. It's an amazing tool. But before I get into that, let me introduce myself. So I've been in the blockchain space for the last 7 years, 4 years with rollups, plasma scalability, and layer 2 solutions. So this started with doing blockchain research at Omisego back in 2020, where I worked on maintaining plasma contracts and introducing new updates to plasma problems. And then at Boba Network, it was around rollups and layer 2s that supported smart contracts and all of the research plus building out like an optimistic rollup and the features that we're going to talk about. And then right now I'm a grad student at UC Berkeley, and that's where I'm also doing my research with blockchain at Berkeley. But yeah, coming back to our talk. We're going to have 4 parts, but we're going to spend more time with part 2 here, which is basically a tool, Codecaster. But before we jump into Codecaster, we're going to spend like 5 to 10 minutes around what Boba Network is, what hybrid compute is, just so we don't assume you have any prior knowledge. And then we're going to look at some code and then some future prospects and applications of Codecaster. All right. And I'll try to take questions at the end because I can't see the screen right now, but hold on to them and we'll just get to that. All right. So let's start with what is Boba Network. As you might have seen in the previous sessions, or you might have read, Boba Network is a compute-focused layer 2. And what does that mean? So as you all know, Ethereum isn't very scalable. Transactions are getting more expensive, and the speed is not relatively as high as some other layer 1s are. So there's this inherent need for a layer 2, a scalability layer that could exist on top of Ethereum and make transactions cheaper and faster. While that, we don't want to give away the security of layer 1. So a layer 2 should basically borrow the security of Ethereum if it's over Ethereum. So that and Boba Network is this kind of a layer 2, which is an optimistic rollup. So basically, transactions on this layer 2 or this chain are rolled back onto the layer 1, and you wait an optimistic period of time to ensure that the transaction that was rolled back and the state resultant state is valid. So not only that, Boba tries to augment the base layer 1 capabilities. So while a layer 2 can scale Ethereum, maybe it has the power to do more because it is a new chain, only sharing the consensus with the layer 1. So it is at a position where you could offer more features, and Boba does that. And one of them that we're going to basically talk about today is hybrid compute. And so essentially, layer 2 makes the layer 2 makes the layer 1 faster, cheaper, and in this case also smarter in terms of the features that it could provide. So we talked about hybrid compute and this feature. So what exactly is that? Now, hybrid compute allows any smart contracts on the layer 2 to interact with services, APIs, off-chain, and all of that in a single atomic transaction. So you might have worked with oracles where you fetch external data, but it's kind of asynchronous where you send a request and then you wait for the oracle to send in the data on chain. But with hybrid compute, it's all in a single atomic call. So just make the request and you have it in the single instance of the transaction execution. And you also can take any complicated logic off-chain through hybrid compute. So essentially, it's either accessing data which is available off-chain from your smart contracts, or you can move computations on your smart contract off-chain. Now, what can that result to? So that can open several avenues for you. I've listed some of them here, but we can really build a huge computational MMO game on Web3, maybe a lending platform which is based on like ML evaluation models that can exist off-chain. You can have KYC, 2FA, for example, Twitter verification could or OAuth could also be things that you could do. And interestingly, you could also check the validity of an optimistic rollup through an external API and use that on contracts to make sure that your transactions are valid. Perfect. So that was hybrid compute, but how does it really work? Or specifically, how does hybrid compute v2, which is the current version in Boba Network, how does that really work? And that works on account abstraction, or this flavor of account abstraction, which is ERC 4337. Now, to give you a brief about 4337, these are essentially all that you need to know in order to follow our topic today. So 4337 essentially has these four parts, which are a user op. So user op is essentially a replacement for a transaction. It is basically a transaction intent. So the way you send a transaction on chain and it gets included, the user op essentially does that, but it doesn't get included on chain. It's just an intent of what you wanted to do on chain. And the bundler essentially accepts those user ops and translates it into something that could be sent on chain. So the bundler kind of exists as a middleman, which takes your user op and translates into something that here the entry point could look at and control your smart account here. So your smart account is like a smart contract account, but then it's built such that it can have validation methods inbuilt in it, and it doesn't have to be executed or utilized through a transaction, through a normal transaction. It can be used with a user op. And how does that happen? The entry point controls all of the user op that is going in and for example, gas deductions and stuff like that. So the smart account and the entry point, these are the on-chain aspects, and the bundler essentially is like an off-chain service, just attaches to the chain, and user op is something that you send to the bundler. And this is a diagram from the official 4337 docs. Essentially, the thing we discussed. User ops are sent to the bundler puts all of the user operations in a transaction, and then it gets bundled into the chain. So what does hybrid compute do using 4337? It tries to modify the bundler such that essentially there's like two main aspects that is changed for the bundler in order to make hybrid compute work. One of them is the estimate user operation gas RPC. So what it does is when you send a user up, you try to estimate the gas that it's going to take. So this modified bundler does that, and in addition to estimating the gas, since you're doing an off-chain RPC call, it tries to save the results into a cache. So this is like a first point of change, mainly in the bundler. And the second point is once you have that result on the cache, and when you're sending the user operation finally, the result is placed before your user operation or your intent. So in a way, your contract tries to read from this on-chain contract, which is called Etsy helper. And this contract is populated right before your user operation comes in. So it kind of front runs your transaction to get the information in so that your transaction or your user operation can read from that information, which is already available. So yeah, if you look at hybrid compute, how it works with account abstraction, this is essentially like a very narrowed down diagram. So you send your intent, goes to the bundler. If it's cached, if it's not cached, then you get the request from the off-chain RPC, store it, And if it's cached, then you fetch it from the response cache. So this is what it looks like on a contract. So notice the line where it says ha.call off-chain. So this is essentially where the off-chain call is happening, and get price is like a method which is registered on your off-chain RPC server. So your off-chain RPC server is told what you want to get with the request, and then once the result is available, as you can see at the last line, we decode as per your off-chain RPC to get back the price. This is just an example of how it's utilized in a contract. So to recap our introduction, HC, HybridCompute, allows you to fetch arbitrary data off-chain or maybe even perform complex computations. And to do that, you have to deploy some contracts, HybridCompute account. You have to build this off-chain RPC, specify it, and update the URL on the contracts to use HybridCompute. So that's great. That's a lot of features, but where do we really go from here? Or how can we make it simpler, or how can we make it better? So this is where Codecaster really comes in. So Codecaster starts with an ambitious goal, which is to assign HC to a single address, which can be available on chain and can respond to your request. So what I mean by that is, we have HybridCompute. It's a feature that allows you to do stuff, but how can we assign that to a single address on chain that is available to you for use? And how can we make it simpler? So essentially that means this address needs to give you responses to whatever you requested, and that could use HybridCompute. Now, can we also make the requests easier using HybridCompute? So it's like a layered HybridCompute approach where not only are your responses computed through HybridCompute, but your requests are made easier. So what do we really mean by that? So first of all, the responses are essentially what we need are call data, because a call data on an EVM chain is essentially anything. Call data is essentially anything that could impact anything on chain. So everything that can be done on chain can be translated to some form of call data. So any operations that you want to do, interact with the contract, deploy a contract, move funds, all of that comes down to call data. So what we essentially need from HybridCompute to do is generate this call data. And how can we make the requests easier? With the power of Gen AI, we can probably use English or natural language to make this request. So what that essentially means is we have an address, for example, something easy to read like this, and that address understands English as call requests. In other words, we have built an on-chain text-to-call data generator. So an address that takes your request in English and does what you want to do, want you to do, and it does it for you. So to check this out, let's actually see this in practice. So I'm gonna give you a moment to look at the links. Not sure if I can paste them, but I'll just give you like 5 seconds if you wanted to copy the link and do it with me. All right. So we move to this link first. Now, since HybridCompute will use account abstraction, we created a MetaMask snap, and this snap needs to work with MetaMask Flask developer distribution for now. But soon enough, hopefully MetaMask integrates snaps into the main extension, custom snaps, and then you could just use it from your main MetaMask wallet. So since we're using the snap, so once you visit this page, you're going to be prompted to install the snap. And once you have MetaMask Flask, this should literally just work. And the first thing that you want to do is create an account. And if you go to this deterministic account, it essentially takes entropy from your MetaMask Flask extension and kind of creates deterministic account from that. So whenever you come back to this page, or if you delete the account from this page, you can regenerate those same accounts. So if you click create account, that's going to create an account like this for you, and it's going to show up. It's going to also show up on your MetaMask extension. Now, I'll not create an account because I already have two here, but feel free to do that. Now, once you have created an account and your account is kind of funded, so I've already pre-funded my account with some ETH, but yeah, these are like smart accounts, and once you have like pre-funded account, you can move on to our next screen, which is essentially Codecaster. All right, so I'm gonna press the page. All right, and I'm connected to my smart account, which is my account abstracted account, Snap account 1. Perfect. So to demonstrate what Codecaster does for you is just like a chatbot. So for example, transfer 0.001 ETH to, let's say, an address that I can see clearly, maybe this one. Go back. Let's try doing that. Give it a moment for the MetaMask pop-up. Yeah, it could be slow sometimes depending on network, but yeah. So our snap shows us like a pop-up box, which essentially is, so this in our case is the Codecaster address, the address which accepts English and does things for you. So all of the instructions that you send are going to this address. It's not happening on the front end side of things, but then the English text in its plain form is going to this address. This is the transaction data. Let me try to copy it, and I'll probably like show you later. And then I'll approve it, and I get a success. So my user operation was added to the bundler, and the bundler probably executed it. Transaction completed. Let's see that, and let's see if the transfer actually happened to this address. I think it did, but we'll just confirm on the transaction. Yeah, so I think the transfer really happened. So let's see what happened on this transaction for more clarity. So this is essentially what the bundler does on chain. So we're gonna look at that here. So if you can see, I tried to decode it UTF, and this is essentially the string that we sent. Now, all of this is like the handle ops data. Let's actually try to look at that. So I'll take this and I'll try to decode. Oh, yeah. So let me actually use the previous input data that I have because I replaced my clipboard. But yeah, if you notice the call data that we had on the pop-up box showing up, and the call data, if you use that, if you decode that, it's going to look something like this, where it's going to call do it, a method, and then the inputs are essentially the string that you want it to do. So do it is basically a function on this Codecaster address, and you essentially just input the English text, and it does it for you. Yeah, we're going to look at more examples, but let me come back and talk more about Codecaster. All right. So what you noticed right now was me using Flask and typing the message, the input on the web page, where there was something like a chatbot, and you entered what you wanted to do, and it did it. But in the future, you don't really have to do that. What you can do is, if you've noticed your MetaMask extension and then the send button, you'll see something like a screen like this, where there's the asset that you want to transfer, the amount that you want to transfer, and then something called hex data. Now, if you enter any English text and convert it to hex and send it to the translator without any context at all, just the hex data and the translator, that should be enough. So essentially, there's this address on chain where you essentially just send a transaction with the English text, and it does it for you. But yeah, since snaps are not not adapted to MetaMask extension fully, we don't have this feature yet, but it is possible. So essentially, what Codecaster is you can probably do something like a swap by just saying swap 100 Boba for ETH on Oolong swap, and it'll do it. Maybe something like approve, and or even like something like transfer, which we just saw. You can also combine off-chain requests that involves hybrid compute, like transfer 100 USD worth of ETH to Bob.eth. Now, if you notice, 100 USD worth of ETH is something that needs like an off-chain component to, or a price oracle to analyze it for you. So here you're combining this transfer feature with one other hybrid compute instruction, which is what is 100 USD worth of ETH. You can also have a condition-based intent or execution. For example, if there's a real-world condition, for example, if it's sunny in California today, transfer X ETH to Bob.eth. So this also includes like a hybrid compute off-chain aspect, albeit maybe not like a price oracle, but maybe something more complicated, maybe using a weather API, for example. But yeah, you can do that with Codecaster. So let's look at that. For example, if I'll say it's morning in California, you can literally use any way to mention your transfer request or your proof request or request. So I'll just say, I want you to transfer 01 ETH to Alice.eth. And yeah, you get the idea. So if this condition works, we're gonna execute the latter part of it. Now I'll try to copy this again. And that should do it. What was our call data like? The call data was what we typed. And again, we're calling do it. Specifically, you do not have to call the do it method on the Codecaster address every time. What you can also do is just call its fallback function, or which is just sending the transaction without specifying any method to it. And this goes in the transaction data. So it's not even like a function call. So you don't have to know anything about the Codecaster address. But we're going to talk more about it, why we're calling do it here, but you necessarily do not have to. Yeah, I think the transaction did complete. We'll see. Yeah, I mean, you get the idea. So I lost some balance and probably Alice.eth received the amount. All right. So you saw a lot of things that we can do with Codecaster, but the benefits are not really limited to the chatbot or to having this interface where you could like type things and make do for your interactions on chain. These calls are for your contracts, and that's the main motivation behind Codecaster, because an interface doesn't necessarily have to be on chain. The translation doesn't have to be on chain, could be off chain, but something for your contracts definitely has to be on chain, and that's where Codecaster really shines. So, for example, this is an example where you're using Codecaster on chain on your contract to make an English request, and it does it for you. For example, this method here, it transfers a price for a certain condition. It'll call the translator contract. And if you notice, it's just a call, so it's not calling any method specifically. But this translator address is being called with an instruction in English, and then that essentially should do the job for you. And if you notice this other method here, it's called approve Boba, and here we're calling a method, and this is to get back a call data. So in the first case, the call data is being generated and executed, and in the second case, we're getting back the call data on this method and then executing the call data in the context of this contract. Just because in the approve Boba case, you have to approve it from the context of the contract, otherwise it doesn't really work. So yeah, so This is only possible, the contract-to-contract interactions are only possible because of having hybrid compute, because it lets you do stuff on-chain. So how does Codecaster really work? So we're going to take a look at the code, but before that, I'll just give you a brief overview of the components. So if you look at the left side, there's like smart contracts, smart contract counts, and any contract essentially that interacts with translator or translator slash Codecaster essentially goes on to our hybrid compute off-chain, and the modified bundler is essentially what makes all of this work. And what does the modified bundler essentially work with? There's a HC helper contract which exists on chain, and this contract has all the logic of permitted colors, deductions, error codes, basically what helps hybrid compute work, and all of the cache and the result data is stored as a map on the HC helper. So the bundler essentially works with the HC helper and this off-chain RPC that you specify to essentially get the results into the HC helper, and so that the translator can read it from it. And the off-chain RPC here, it works with this AI component to basically analyze your string input and get you the results that you want. So magnifying on that part, Codecaster uses a general purpose AI like ChatGPT, OpenAI API to parse your string instruction. So it scans for identifiable parameters. For example, when you enter a string, it tries to give you a tuple in the form of this. So you can use that tuple for further and design a call data from it. So the off-chain RPC gets the instruction, uses the general purpose AI to scan it and map it to identifiable parameters, and then parameters are used to generate the call data. Now, we're using a general purpose AI, but really the stronger the AI model, the stronger is the call data generation. So now we're doing a lot of heavy lifting in terms of generating the call data from this tuple, but that could get easier with like more efficient AI. So for example, transfer 0.01 ETH to Bob.eth, the string will be parsed into this tuple where transfer indicates what the action, and then this is the second is the sender, then the receiver, and then the crypto amount, and then the crypto token, and then the next parameter, which is no, is essentially if it's a fiat, if there's a fiat prompt. So for example, if you see the second prompt, there's like 10 USD worth of ETH, and it says yes because there's like 10 USD, and if it's yes, and then what is this fiat, and then USD. And then the last parameter is swap. So we don't have a swap in this instruction, so just goes blank. But yeah, this is a very minimal implementation where you just have like transfers, swaps, and approves the general items because our AI is minimal as well. So similarly, yeah, swap and condition breaks into two parts, where the first part is a different hybrid compute invocation where you're looking at a weather API, and gives you like 3 parameters that you can use to find a yes or no answer, which is preceded by our general parse tuple. So let's actually look at some code and see how this thing works. So we've been talking about this Codecaster thing, and it's an address on chain that allows you to do stuff with just natural language instructions. So this is our Codecaster contract. So this contract can be pre-deployed to a very readable address on a layer 2, or you can have a central source of truth where you can like have the contract addresses listed, so everybody knows what the translator address is. But what the translator address really does is there's a method called doit. I think we've been looking at doit when we're looking at the call data. Now, the doit method essentially takes your instruction, generates call data from it, and then executes that call data. So at this point, we're calling HybridCompute with the request, which is the instruction, and text to multi is basically our off-chain RPC. Is an off-chain RPC method. So it's such that the off-chain RPC identifies what our request is, because we can have multiple types of requests, as we'll see down in this contract. So simply text to multi, the off-chain handler, which we'll again see later, gives back something like instructions. So it's like an array of instructions depending on what your request was, what your instruction was, and then loop through the instruction and decode the instruction to find target value and call data. These are basically the parts of the transaction, and then you execute the transaction from this contract. So essentially, you get the call data and then you execute the call data, and that's what we were doing with calling the do it method. Now, as an alternate for it, if you go down, the fallback method essentially does the same thing, but you do not need to call any method here. What you can really do is use the message.data here, the hex data that you pass through transaction to this address, and then use that to send this request to HybridCompute and then get the call data and then execute the call data here. What else does this address allow you to do? So in several cases, like for example, the approve case that we saw, execution has to happen in the context of this contract. It cannot be, or execution has to happen from the context of the sender. So you cannot really have this contract approve it, which wouldn't make any sense. So in these cases, you got to get back the call data instead of executing it. So what you can do is similarly use HC to call off chain and get the call data as a return. And you loop through the return and you just return the call data, the target, the transaction essentially. And this is the call data. So when you return that from this function, your contract, on the other hand, can use this call data and execute it on its context. So for example, for cases where the context needs to be managed or context needs to be specified or cannot be an arbitrary context, you essentially can get back a call data from the Codecaster address to further use it on your contract. If it's kind of still kind of vague, we'll actually look at a contract which does that. So more on that later. What other does the Codecaster address allow you to do? Get back general. So this is where it tries to be more than just like a call data response address. So it takes an instruction similarly, but then the get back general is for a general AI request. So if you notice, it's calling text to general on the off-chain RPC, and that returns simple bytes, simple string of bytes, and then we convert that into string and return. So for example, any off-chain RPC call that you need to do and which returns a one-word answer is a great candidate for this. For example, if you want to get a random number between 1 and 100, which is a prime, you can just mention that on the instruction, and get back general will give you the answer. So all in all, you do not really need to set up HybridCompute at all. Just give your request to this translator or to this Codecaster address, and that gives you the results without having any setup phase at all. So that's Codecaster. Now, Codecaster, you might have seen it works with this HA for sending the HybridCompute request. So hybrid account is a contract that you need to set up, and essentially uses essentially allows you to authorize the callers that are allowed to call your hybrid account. It keeps track of the deposits that you do or the credits that you want to use for HybridCompute calls. Now, this is what we were calling on the hybrid account, and it again tries to call off-chain, and hybrid account essentially calls something called etc helper, and this is the contract where the responses are stored. And it also has a lot of error coding, and this is essentially the contract that HybridCompute uses. So single contract on chain, and put responses where the response is put, and then the system user up is prepended before your user up to get the response in here in this contract that could be read by hybrid account and indirectly translator or Codecaster. Let's look at our backend. So we're looking at this method here, and what it essentially does is takes your request, and if there's a condition, then you decode that in the form of AI call, which is further up here. So you basically have like a general GPT response to find the tuple and assign values to the tuple. And if it's not a weather condition, if it's a general condition, for example, transfer or a swap or an approve, for example, then you do a response, simple transfer, response token transfer. So let's look at that. So response simple transfer essentially generates the call data for you, which is for a simple transfer, and a token generates a call data for an ERC20 transfer call. So this is what the generation looks like. Yeah, and the response encodes all the tuples together and then returns it to the bundler that can further generate the response from it and send it to your Etsy helper. So that was the Codecaster code. And feel free to find the GitHub repo here. And the GitHub repo also has set up instructions for Codecaster on a local device, so you can set it up on your own device. Or you can probably also, if you don't want to do that, you can go to this link and try it out right now. Yeah, let's move on to applications and the future of Codecaster. Now we're at a point where we discussed a lot of features that Codecaster offers, but the future really depends on what the AI can do. Now we were working with a general purpose AI that essentially takes a string and converts it into a tuple of identifiable parameters that can further be refined into a call data. But if there's an AI, for instance, which takes your string instruction and generates call data from it directly, like a very blockchain specific AI, then that could essentially be a huge progress to this kind of solution. And call data essentially means anything. So any activity that you want to do on chain is call data. And if you can generate call data efficiently or effectively, you can literally do anything with English instructions. And depending on the adoption of account abstraction, in the future, there'll not be a need of an extra UI. You can just use MetaMask because remember, we're interacting with an address that just takes transaction data and can use that to get requests for you or do requests for you. So yeah, again, so this is what it could look like in the future. Just use your MetaMask extension like you use now to do requests. So the benefits of Codecaster, really, to recap, are it simplifies interfacing for your contracts, so you don't have to set up a web off-chain RPC API anymore. You can just do requests, and then the AI in the back end really generates every response for you, and it's through an address. So limited HybridCompute to this address, and then it also simplifies contract writability. If it's a complicated smart contract solidity logic, then you can just push it off, just push it through an off-chain English response. So what you can do is write what you need to do in English, and the computation happens off-chain, and the results are pushed back on-chain. So you don't really need to write code if you can use Codecaster, which we're gonna see that example at the very end. And looking back at our ambitious goal, it does also simplify Etsy usage. So it's not just an on-chain text to call data generator, but it simplifies HybridCompute usage by being like a single address which is available on the chain that can help you do arbitrary computations, just like HybridCompute does, but at a single address column. So you can also, depending on the AI, you can get any information from the internet as well, just by calling an address. For example, so we looked at this example where you can get back like a general AI response, not call data at all, and get that on your contract without having to set up anything on HybridCompute, just having this line on your contract. So let's look at a complete contract example to highlight the benefits of Codecaster. So here's a sample contract, which basically is like a lottery where you pick numbers and then a winning number, the person who picked a winning number gets the prize. So as you can see, I've not written a lot of solidity in this contract, and I've used a lot of Codecaster to simplify it. So a lot of the logic, solidity logic, has been abstracted to Codecaster. So for example, here we're picking a winning number, like you saw. It gets the winning number, which is a random number on chain, and then transfer price uses do it, or you can also use this form, which is essentially not calling any method at all. But yeah, you say transfer 100 UZ worth of Boba tokens to the caller, and depending on this condition, you basically execute this. So as you can see, there's no transfer, no other logic, solidity logic involved in this method, just to translate call. And approve here is to approve this contract, and for that you need to execute that approve call in this context. So what you need to do is get back the call data and use that to call in this context. So so it effectively reduced the size of the contract in terms of the code that you need to write, made things easier in terms of things that you need to get, and that is essentially Codecaster. So thank you everyone for listening in. I'll now take questions right at the 45-minute mark. If you have any more questions that you don't want to put now, you can always reach out to me on Twitter. But yeah, thanks again for listening in.
Amazing. Thank you so much, Souradeep. Yeah, perfect timing. So we do have some time for questions if anyone has them in the chat. But that was such a well done presentation, super in depth and super interesting. So I hope you all found that very educational. Would you mind potentially sharing the link to the slides in the chat? And then
Absolutely.
we can share that to our kind of like in our YouTube description and stuff, so everyone can have access to that, because I feel like that would be quite useful.
Absolutely. Let me try to do
Amazing.
that.
Thank you so much. And yeah, if anyone has any questions, feel free to pop them in the chat. I think Austin Motley asked a little while ago if prompts are posted on chain.
Oh yeah, let me take that question. Sure. All right, you should have the link right now. Perfect. So
Amazing.
yes, so as you saw, we were basically posting those English instructions on chain, and that's what essentially HybridCompute allows you to do. So all of that English prompts, for example, transfer 1 ETH to Alice.eth, is posted on chain. It's a transaction data on this transaction that is sent to Codecaster address, and yeah, HybridCompute takes it from there. So that really, posting it on chain really allows your contracts to use this feature, and not just you as a user, as an end user using an interface. So that's what really is.
Great. Very nicely explained. If there are any other questions, feel free to put them in the chat. But this workshop will be recorded and edited and uploaded on our YouTube tomorrow, so everyone will have access to that. Souradeep, thank you again. That was really a really good workshop. And yeah, if people have questions, just put them in the chat, and we can get to answering them. So yes, but of course, it was also very, very clearly explained. So if there aren't any questions, that's also totally fine. Oh, I think we have one.
Okay. So what are the security considerations to consider when using this tech? That's a good question. Now, these definitely needs to be more eyes and more work that needs to be put in this case, because now you're trusting in AI to generate call data for you. So as we all know, AI cannot be perfect all the time. So when you're trusting in AI, uh, and you want everything to be deterministic on chain, otherwise it's not smart contracts, it's not blockchain code. So there could be checks and balances where, for example, if you're still using Codecaster to use an off-chain, to use AI to get your call data or get your responses, you can still have like checks or balances. For example, what do you do with oracles today, price oracles today, to ensure that it's still on track? So yeah, that's definitely a good question, and a lot of work needs to be done there. But I feel checks and balances could take a lot of the heavy work, or make sure things are like running smoothly still.
Any other questions for Souradeep before we wrap up today? Like he did mention that you can reach out to him on Twitter as well. Would you mind potentially posting your Twitter in the chat if possible?
Absolutely.
It might be slightly easier for people to access that. Okay, amazing, great, perfect. Well, this is your chance, everyone, to ask questions. If no one has any more questions, then thank you all for coming. I hope you guys enjoyed this workshop, which is the third one in the Generative AI Educate series. Souradeep, thank you again for what a great workshop. Yes, Abbas, the link will be posted for the recording. It will be on our YouTube tomorrow. So if you search up encode, let me send you the link here so that you can have easy access to it. Let me find it, but it's just on our YouTube. Here we go. There we go. So tomorrow morning, this will be recorded and uploaded and put up there. And yeah, that concludes the third workshop of this Generative AI series with Boba Network. And I hope to see you guys on Thursday for the next workshop. Souradeep, thank you very much. I hope you have a great rest of your day. And I hope everyone else enjoys their day. Thank you all for coming. And we'll see you soon. Thank
Thank you,
you.
guys.
Bye. Bye-bye.